All right, continuing with our big idea for data, collecting, displaying, and analyzing data helps us to solve problems and understand the real world. Our concept for today is to demonstrate an understanding of gathering data using a database and then drawing conclusions. Databases are already collected data. Usually they'll have collected the data for you. Examples would be Weather Canada collects data on the weather. Census Canada collects data on the population of Canada. Use already collected data to create a graph. Okay, and we will be creating graphs today. When we are drawing our graphs, there are a number of things that we need to consider. The title, first of all, should be very specific as you can about the information that's in your graph. No title at all makes that graph almost essentially useless because you do not then know what the graph information is about. If you can be as specific as possible, that would be better. You need to have axis titles. So you need to have a title on each axis, and the axis are the sides. So you need to have a title on the x-axis, and you need to have a title on the y-axis. Again, each title should be fairly specific. If it's related to units, so centimeters, millimeters, that kind of thing, that should be there. If it's related to money, that should be indicated. If it's related to temperature, that should be indicated. When you are numbering, it's really important to number the lines, not the spaces, because it's very hard to see if a dot is in the middle of a space or a bar goes to the middle of a space. It's very hard to see what that's actually supposed to be. It's not as exact as it can be if it's numbering the lines. So just like we did when we were doing the patterns unit and we talked about numbering the lines, continue on with that same practice, numbering the lines, not the spaces. As well, when you're numbering, remember to number in regular intervals. So counting by 5s, by 2s, and so on. You must start at 0. Okay. Remember, the numbering is also called the scale. So when any question asks you about scale, that's what you're looking for. You cannot jump when you're numbering. So I cannot say, okay, I'm numbering by 3s, but my first piece of data is at the 1. So I'm going to go 1, 3, 6, 9. I'm now counting by 3s. Well, technically I'm not because 1 to 3 is by 2s. So be careful that it really is by 3s all the way along. Realize that the numbering intervals or scale does not have to be the same for both x and y. So this numbering can be different than this numbering. Maybe this one goes by 1s, this one goes by 2s. That's fine. Lastly, or almost lastly, a legend may be necessary. It must be included to tell the color or the pattern of different sets of data, especially if doing a double bar graph or a double line, broken line graph. Finally, all graphs must be drawn on graph paper. So today we're going to look at drawing those graphs based on data we've collected from a database. So let's take a look at some drawn graphs now and determine what makes a well-drawn graph so that it is clear and the data in it can be easily determined. So to practice, here we have some data that was collected from a database. We have Lawrence and Lon, who have a baby sister, Lacey. They've collected data about Lacey's weight, and each of them made a graph to show how fast she's growing. So let's take a look at their two different graphs, and we'll see how the numbering, the scale, the way that the graph is drawn makes a difference. So we have her age in months, her weight in kilograms. Excuse me. All right, so in fact, both show the exact same data. You can see both of them are well drawn, graphed in that they have the titles, Lacey's weight, I would probably have added from birth to 36 months, just to be clear, but that information is there. Age, and it's clear it's in months, not years, so that's good. Weight in kilograms tells us what that weight is in. So they have all of that information accurate. On the bottom here, they've numbered by sixes basically, but really they've left another set of lines in between. So really it's by threes, and they've just labeled every second one. So really this would be 3, 6, 9, 12, and so on. And Leon has done the same. Where we see the difference is here in the numbering on the side. Now let's go look back at our data, and we can see that the weight goes up to 14.2 kilograms from 3. So our numbering by tens here, or actually it is by fives, because we can see there's a line in between, so it would be 0, 5, 10, 15, 20, and so on. So they've numbered by fives. Was numbering by fives your best choice? Which graph demonstrates the data better? Well, really, we can clearly see the data better here. It's more of a substantial rise. We can see how much that's gone up. Whereas here, our data looks very flat, when in fact she has grown a fair bit. So it doesn't really, truly demonstrate the data as clearly as possible. So numbering over here by ones, in fact, because 1, 2, 3, 4, and so on, is much clearer in this case because our data is so small. We only go up to 14 point something kilograms, so we should be numbering by ones at the very most, by twos, certainly not by fives. So this graph more clearly demonstrates the data. All right, now you are going to use a database to collect data and then to draw conclusions based on that data. So here's the link that you're going to use. It's the Census at School data. The latest results was 2010-2011, so use that information. You can pick whichever topic you want to create a line graph or possibly a double bar graph. Draw the double bar graph or the line graph, and then make 4 excellent conclusions about the data. Now, excellent conclusions are very specific conclusions. So let's take a look back at the information. All right, so let's take a look back at the data for Lacey and see if we can make some conclusions. When we're making excellent conclusions, they are very specific. When we are making adequate conclusions, they are not very specific. So for example, I could say that she weighed the least at 0 month or at birth, and she weighed the most at 36 months. Well, that's extremely obvious, so that would be adequate. To make a more specific conclusion, I could say she gained the least amount between 18 and 24 months. That's more specific. I've been quite specific about that information. I've related 2 dots on the graph. I could even say, be quite specific as well and say she gained the most amount in 0 to 3, 3 to 6, and 6 to 9 months, with approximately 2 kilograms being gained each time. And that would also be very specific. I've told them the difference. I've related 3 different dots to each other. It's been really quite specific. If I just say at 12 months she gained 10 kilograms, that's talking about 1 dot. That's reading a dot. That's not even a conclusion. I haven't used my information or my knowledge about the information to figure something out. I've just read 1 dot basically. So that is not a conclusion. So be careful when you're making your conclusions that they're not just reading 1 dot, that they're comparing the information. All right, in fact, the information has changed on the Census at School website, but if you just type in Census at School and you end up going to the students option, that looks like this. And then if you go to data and results, that looks like this. And from there, you can choose the summaries results of Canada 2011 and 2012, and that's even more specific information. And then you can do your graphing from there. So if you have any trouble finding the graphing or the database, let me know and I can assist you with that. And you are going to then choose whatever data you find interesting. As you can see here, there's quite a list of information that you can choose from that Canadian students have replied to. So pick whichever one you like. Create a double bar graph or a line graph or a bar graph. Remember to use the criteria that we discussed at the beginning of the video. Rewind back if necessary. And if you have any trouble along the way, please remember to ask.